I will grab water. Hi YouTube. It wasn't optimal what I did. I clicked go live on YouTube and then I went to grab water. So I think for people on YouTube, when they open the stream, they will not see me. As I said, not optimal. Hi Hkn2 underscore. Perfect nickname. Once again, I'm following this list suggested by somebody in my Discord server. By the way, join the Discord server. First warm-up problem will be maximum subarray min product, and then two hard problems: bricks falling and rank transform of a matrix. We start with this one. Hey everybody. Have I ever applied for Google? It's more like Google applied for me. Google invited me to interviews, but I didn't want to work for them. Why would I? Everybody thinks that Google is a dream job. It's normal software engineering, just everybody around you is smart. I'm sure that their code quality is better than an average company. That's the main advantage. Links to all three problems. That might be a good idea. Here we go. Links to all three problems. What do you work now? I teach. Google pays less. That's also true. In Warsaw, Poland, Huawei pays twice more than Google. It's not that good to go to Google right now. Quantitative researcher, no. First problem, maximum subarray. I don't know the solution, by the way. I only glanced at problems. Can you zoom? Better? Min product is minimum value in the array multiplied by the sum. Right, so we want, if possible, we want all numbers to be big. Even a single zero would mess up the whole thing. If you have the array with zero, then the whole product becomes zero. Given an array, return, find the best subarray. As an example, if the input is 1, 2, 3, 2, we can take everything as the subarray, and then the score is 1 times the sum. So minimum times the sum. What's the sum of those four numbers? 7, 8, 8. So the whole thing has value 8. But if we drop 1, and if we just take 2, 3, 2, we have minimum is 2 times sum is 7. That's 14. It was very beneficial to raise the minimum. Be a little hard? You mean the second out of three problems? I don't know the details. It looked fine. Yeah, I didn't do biweekly. Yeah, that's right. I don't think I will keep doing biweekly. The views weren't that good, so I prefer random problem solving. Or even better, I will try to focus on one topic in the future every stream. But I'm not doing biweekly anymore. Voice is coming funny. Does it? Something wrong with my microphone settings? No, everything seems standard. Mustafa Saad's training sheet? Yeah, it's fine. Okay, I will talk a little bit about the problem, and then I will give you a few minutes to think about it. But not too much, because this time the problems were chosen in advance, and if you are part of my Discord server, you would know the problems already. Funny, the background. Oh, it's not fun, it's just open window. I might close it later. Not necessarily though. Okay, if you take everything, the sum is maximum possible, assuming that there are no negative values. Yeah, everything positive. So take everything, small min, big sum. And this might be bad because of the small minimum. You cannot get bigger sum, but it makes some sense to raise the minimum. This is a trade-off. And the sum can be huge. It's not that you will iterate over the sum, but minimum is one of elements in the input. So it makes sense to think about this minimum. Maybe for every possible minimum, we will figure out the maximum sum we can get along with that minimum. Right. Now let's try this format of a stream where I give you a few minutes to think about this, and while you have time, I can also answer unrelated questions. Well, still about programming, but we can chat. You can ask me again why I don't work for Google. I closed the window because it's hotter outside than in the room. Similar to histogram problem, that's right. Constraints, good point. Constraints are that everything is up to around 1 million, let's say. Why don't I work for Google? Good question. Because I don't wanna. Why is my chair so low? Google is perfectly fine if you want to work there. Like, all day good luck to you, but I don't wanna. I prefer teaching than normal software engineering. Thinking time format, I like it too. Explain yesterday's problem E. No. I will not solve Codeforce's problems today. Why don't I work for Huawei? I considered working for Huawei because it pays a lot in Poland, in Warsaw in particular. I might want to work for them. It's really, they offer crazy money for Polish standards for some reason. Right now, if I'm going to do any software engineering in next months or a year or two, I will go to Huawei. It pays more than twice as much as Google, so why not take that? I don't think that the job is that much different. Why use C++? It's convenient and fast for competitive programming. Code chef lockout, if I'm invited, I will consider. Working for Apple? Sure, I can consider, but I'm not an Apple user. What do I say to Google when they contact me for interviews? I say that I'm not interested. Link to my chair? I don't remember the name. Train people for IOI? Yes, I do. Actually, I have an available spot. You know, I have those 3-person group classes. Groups. We have weekly lessons. Each is 1.5 hours. The cost is $85. And I have slot available for ICPC level, or Codeforces around 2100, and Leetcode medium. In those two groups I have a spot available. If you want to join, then DM me somewhere. Right. Thinking time is over. I don't want to just make this into a huge Q&A. But I do give group classes. Gupta, I actually said that they can ask questions, so it was fine here. Like, we can do this 5 minutes of chatting. Now, back to solving the problem. Chat, any ideas? If you didn't know in advance, or if you didn't know a week ago this problem, give me some idea and we will discuss it. Perfectly. I would like to hear some wrong ideas. Maybe use stack plus prefix sums. I don't like this idea. Somebody said maybe use stack plus prefix sums. It's very vague, and it seems that you're saying about techniques we need to use at the end instead of really an approach how to get there. Right? It isn't enough here to say that we should maybe use a stack. Like, that's so, it seems to me so unrelated to the problem. I would say that we can analyze what is going on, and then it will turn out that we use a stack. At least that's my feeling. But if you come up with the idea of using stack here, which might make sense if you think about histogram, because this problem is very similar to histogram, max histogram or something like that, and you use stack over there. But I would say that it's not that because of that here we think about stack. Because of that we maybe want to apply the same logic from max histogram here. Those are not same problems. They differ a little bit. Max histogram is length multiplied by minimum, and here we have sum multiplied by minimum. Here's a wrong idea. Use graph. I agree. Some people mention dynamic programming. Dynamic programming very rarely works for high constraints. DP usually means n squared complexity or worse. So in Leetcode, if you see constraints, you will mostly see that DP shouldn't be used. There are exceptions to this rule, but DP is rare for something like this. 2 pointers will work, but 2 pointers doesn't work for histogram, does it? For each element, consider it to be the minimum of the subarray. Yes, this is. So, who said that? Space Islers. This is very good start. For each element, consider this to be the minimum, because we want to pair up minimum with the sum. There are n possible minima, and maybe for each of them we will say what is the possible sum. And now, given this first sentence, stack makes a lot of sense. Yes, numbers are positive. Sort break the subarray? We cannot sort the input because it messes up the order. No, I will not solve biweekly. Yes, it should be n log n or O of n. Cadence algorithm? Nope. Cadence will not do anything smart if all the numbers are positive anyway. So it will try to take everything. Right, we start with this sentence. For every minimum we want to know what's the max we can get. Now we can think whether that similar problem, max histogram, whether it offers exactly that. So do we use this as part of max histogram? If so, can we apply the very same thing here? What was max histogram problem? We have some columns. We can draw columns, but they have some heights, like let's say 2, 6, 8, 4, and maybe more. And now if there is some increasing part, 2, 6, 8, but then you see something lower than that, you know that when looking for anything else, like when going through that, you will not anymore use 8 or 6, because 4 hides them. Voice is not as quality as always? When going through that, you will not anymore use because 4 hides them. The sound seems fine. I don't know, maybe a little bit off. But I don't know what's the issue. Monotonic stack, yeah, it's something like that. So 4 will kind of hide 6 and 8. So when we get to 4, it will pop 6 and 8 from the stack, also will do something. Now we have 2, 4. Now if here comes 5, we here push 5. If here comes then 3, it will pop 4 and 5. And as it pops, it also, as an extra, it knows this 3 to where it reaches. So is this 3, basically it can go to the left as far as until this 2. Something like that. This is short version of max histogram solution. But if you don't know that, you need to for sure know. It's a well-known problem. This is max histogram, or max rectangle in histogram. I'm surprised that this is hard and this is medium. Shouldn't it be the other way around? And we try to use the same technique here. So as we go and to do that, for every minimum, we know how far it can reach. And thanks to that, we know, for example, there is this sequence in the input. When I don't know exact elements of the sequence, I like to visualize them as underscores. I look at some number here, 3, and this algorithm allows me to understand that, oh, here, when moving to the left, there is some smaller value here, and I will stop there. But until this position, I have everything greater than 3, so I can use minimum 3 here. If I also know how far I can reach to the right, then I can know what's this size. What is the sum? So solution 1 is use monotonic stack to find previous smaller element and previous and next smaller element for every element in the sequence. For example, for this 3, I want to know that previous smaller is here 2, and next smaller out of here, the closest value smaller than 3 is maybe right here, and that's 1. Everything there is at least 3. Then consider 3 times sum as the answer. The sum, I need to reach the sum of those elements, and in particular I can get that using prefix sums. And then in constant time I can grab this sum. So consider value times sum as the answer. And the sum I will get thanks to prefix sums. And that's it. If we can do the first part, the second one is done. It's easy. What if there are negative numbers? Maybe something will be more complicated, but I don't like wasting time on those other different versions of problems because sometimes they are unsolvable. Great. This first point you should be able to solve. That's easier version of max histogram. Max histogram can be solved using that. But solution 2 is just to kind of directly use the same algorithm as max histogram. And what do we do there? When you have that stack, monotonic stack, and here comes 7, what happens is 7 wants to pop 10. And when it pops 10, you need to know that 10 is minimum in this area. If 8 was on position I, and 7 now is on current position j, then you need to say that everything from I plus 1 to j minus 1 has minimum 10, and you need to consider that as the answer. You do the same in max histogram. And then you pop 10. Because you need indices, I would say that this stack should contain indices as well. So it will be 2 comma some index, 4 comma some index. This I is different, it's index of 4, 8 comma index, 10 comma index, and 7 comma index. And when 7 pops 10, we want to say that everything between 8 and 7 is candidate for the answer. Which solution, chat, do you want me to implement? Solution 1 or solution 2? We can do one of them. This is basically rewriting histogram, max histogram, just with prefix sums as the extra. While solution 1 is using as a black box a very well-known thing of finding previous greater. Still, we need monotonic stack, and but doing that in both directions and remembering those indices. 1 and then 2. No, that's not possible. We're kind of, I see we're not sure which one. Let's say 1. I think 1 is better. So solution 2 is basically solve max histogram. You can do that yourself. Okay, we go with solution 1. Use monotonic stack to find previous smaller element. Let me code this. I wonder if the chat is readable now. I will create a function for that because I want to run it twice. Find previous greater. For convenience, I like to save the size of the array as n. Why would we pop bigger value when small value appears? Because smaller value hides the bigger one. If I tell you the prefix 268 and then 4, and there will be some next values on the right, but they, combined with the left part, they will not use 8 anyway. You can, for the sake of those values to the right, you can say that this is 4. Because those values will not use 8 as the minimum, because 8 is covered or hidden by 4. Okay, what do we do? Array position in A. We need this stack. While stack back is greater than me. Can we have ties in this problem? Ties shouldn't matter. Maybe I need to care about that. For now, let's implement it in some way, assuming no ties. While stack back is greater, stack pop back. Okay, this is standard increasing stack. What did I do? Oh yeah, I wanted to find previous greater. So if it was 2, 4, 8, and then I get 7, 7 popped 8, and now for 7 I see this 4. So I need to at this point say previous greater of I is what? Whatever is at the end of stack. So as I mentioned earlier, it's nice if this stack has pairs value comma index. So I need to compare with the first value. But then previous of I is stack back dot second, the index. I remember the index. Then stack and place back a pair ai comma I. And for convenience, it's nice to add infinity first. Infinity comma or minus infinity? Minus infinity. So for everybody, previous great. Wait, I need previous greater or previous smaller? Previous smaller. For everybody, I need to know how far it reaches to the left and to the right. I can only put index. Oh, Nathan is right. I think that might be nicer. let me put pairs. Indeed, index would be enough here, because given index, I can always access a of I. Let's leave it like that. Previous smaller. Okay, so I'm putting minus infinity so that for every number smaller, previous would exist. All good? This actually will find previous or equal to this one, smaller. But I want to say strictly smaller. While there is somebody is bigger or equal than pop, and then eventually you find somebody strictly smaller. No. I don't like nums. Long name. Previous smaller is find previous smaller of A. Reverse. Run the same. Reverse the result. And reverse A back. And these indices in next are reversed as well, because somebody at position 1 actually temporarily is at position n-2, and all the indices are messed up. So I need to reflect that, mirror it. Now 0 changes to n-1, 1 changes to n-2, and so on. I think that should be good. And now if maybe we'll get something reasonable if I print previous of I, next of I. To -1 for now. Run code. Let's see if this works. Infinity not declared. This is billion plus 5. Better to pass by a constant reference. You mean this? I agree, it's better. It's faster. Doesn't change the time complexity. N doesn't exist because I didn't didn't create it here. Oh, and you don't see the chat. Well, that's unfortunate. Comments. Wrong value because I returned -1, but let's see if this is right. For position 0, the previous smaller position is -1. The next smaller position doesn't exist, so it's n being 4. Maybe it's better if I draw that, I don't know. But for 1, both previous and next greater, oh sorry, smaller don't exist. What about index 1? Can't I mark just a single thing? For index 1, that's a 2 here. The previous smaller is position 0. The next smaller is, again, doesn't exist, so position 4. That's right. Yeah, this is also fine. For 3, the neighbors are previous and next smaller. I think that this is correct, at least for the sample test. I should use long for overflow. Where? I'm not adding any values, so no, I don't think so. I use the same type as was given in the input. For now, I didn't add stuff. Here I reflect the index. It's still from 0 to n-1, maybe also -1 and n. No. For now, no longs. I will comment this out because it might give me time limit exceeded. Printing is slow, so we shouldn't do it if not necessary. Where do I work? I teach. Why penalty didn't happen for this after first minute? Because it was rounded to 250? Come on, that's unrelated. What do we do now? Oh yeah, for every I, the answer should be considered as answer is max of answer and modulo 1,000,000,007. Well, that's tricky. But I need to compute it as long, otherwise it wouldn't work. I need to maximize it. I couldn't take it modulo every time and then compare, because remainders aren't really, cannot be compared to see which one comes from a bigger value. This sum should be sum of numbers between previous of I and next of I. For that we need prefix sums. Like that, maybe this for convenience. Prefix of I is the sum of all AIs up to this position. And the sum is up to next I, but not including next I, minus everything up to previous of I. Unless this is -1, obviously. If this is -1, then I take 0. Like that. Maybe it's better this way. Ugly code, but it works. If you want to make it nicer, you can make this into a function. You can extract the whole logic for prefix sums outside. If this is long, then I don't need to cast here. Int times long will be long. Works for the sample test. If we suggest you some problem, can we do that? Not right now. Today I'm doing suggestions from Discord from before. Sometimes I do accept suggestions, just not today. Grad school or work, the bachelor's is enough, but I would say go to uni, get bachelor's, then go to work. Enums, they are fine. If something is recommended that you should use them, then use them. What is the time complexity? Linear. Everything is linear here. Of and total. We never do any binary search or sorting. The stack is, of course, the least trivial part to estimate, because we have two nested for loops, or for inside while. So maybe it would be n squared. But stack is initially empty. You insert n elements in total, because every element is inserted once, actually n plus 1. So this erasing step can be done only n plus 1 times. You will not erase n squared times, because there are only n plus 1 elements added in total. So this thing is linear. Which website do I use? Codeforces. First problem done. Now we move on. I mean, if you have questions about this, then we can still talk about it. And your homework, if you want something related, is once again histogram Leetcode. Largest rectangle in histogram. That's your homework. I could be a good teacher. Thank you. I am a teacher. So I hope that I'm good. When to use dot and that? I will not teach you C++, you can Google that. Solution at 25 percentile? Doesn't matter, ignore that, time complexity matters, not exactly what values you used, like what type you used. Don't look at the percentile. Start a business in teaching? Okay. I will open a YouTube channel. What about that? Is that a good start? No. Bricks falling when hit. What is this? You're given a grid where 1 represents a brick and 0 is empty space. Brick is stable if some conditions are true. Blah blah blah, some definition, but I think it's... Oh, there's no drawing. Then I will make a drawing. I've read this statement before, and I'm quite sure that it's about this. If some brick is at the top, it's stable. If something touches something in the top block, it's also stable. Here, all of this is stable. But if you removed, say, this brick, then those would fall down. Now, what is going on? We erase some bricks and we need to understand what bricks get disconnected. Okay. I see. It's a bit like saying that there is a graph with some root being the very top edge, and when you remove some node, we need to say which nodes fall down. If this was a tree, so no cycles, it would be easy, because you would say that everything that was connected to it down, it goes off. But it's not a tree, there can be cycles. There can be something like this, I don't know, where there's this huge cycle. And you cannot say that after removing something, it's hard to say whether you should disconnect this or not. And you cannot go through the whole graph again and again. No, this is not strongly connected component because edges are not directed. In particular, given two bricks, you don't know which of them is more important, because maybe the bottom one is actually connected more to the ceiling. Maybe there is a path. Let me draw here on the side. Imagine that there is a ceiling and then something like this. You cannot say, for those two, you cannot say that the top brick guarantees the existence of the bottom one. It's the other way around. And if there are cycles, like here, then here, what are the directions of edges? No, the edges are directed both ways. It's not a directed graph, so it's not strongly connected components. You're all guessing some names of algorithms instead of analyzing the problem. You try to think too much about name of the solution, of type of the solution, asking if that should be used. We should think about this. What happens? Like, I as a human, when I look at this drawing, like the black one here, okay, oh, that will be actually easier to read. And now, if I remove something, like this cell, how do I, wait, I'm not drawing right now. Remove that. How I figure out if my neighbors should be disconnected? Valid ideas, but they don't work. But reasonable ideas are that maybe for each cell we should count in how many ways it is connected to the top. When this value becomes 0, we disconnect it. So maybe that. And all those ideas will fail. You can, after every disconnection, so erasing a brick, you can run DFS for each of its neighbors. So for this cell and for this cell, you can run DFS and see if you will get to the top. Or alternatively, you can just remove this cell, mark it as forbidden, and then run DFS starting from the top. But this is too slow. this means that the number of nodes, let's say V, the number of vertices is up to 40,000. And if you remove all of them, I need to, by the way, reread the statement to make sure that I understand everything correctly. If for each of them, when you remove it, you run the FS through the whole graph, that's V squared. Too slow. We don't want that. What is being erased? What's the size of hits? Yeah, 40,000. So in particular, it's possible that we remove all of them, and you will get V squared. Queries are sequential. We delete, then we delete some more, and so on, I think. Count the adjacent. No, that's not enough. First of all, for adjacent, you don't know if they will fall or not. So even for adjacent, how do you know that you should count them? Like this one versus this one. You don't know which of them is still connected to the top. That's one thing. And the other, that it triggers other things. In this black drawing above, all of this gets erased. It drops. Do I do autocoder sometimes? Only hard problems. Okay. This is a problem where I can imagine even a very strong person just struggling for an hour. I remember that given a similar problem in Codeforces or Leetcode, I don't remember. I just couldn't solve it in a lot of time. Because when I think about this process, I just don't see a solution. There are possibilities like DFS, maybe somebody suggested strongly connected components. So you get those ideas. Nothing of that works, and I perfectly understand if somebody wastes here 30 minutes. Andromeda 1. Do the operation in reverse. I think it's arguably the hardest trick in Leetcode problems. And if somebody in Leetcode takes me more than 1 hour, it will be a problem where we need to do something in reverse. I will try to give you some hint when it should be used, but again, I think it's the hardest thing ever. I never saw in the internet some article, some description that says when we should do that. But indeed, go in reverse. Maybe first hint when we should do this is when we cannot apply it forward. We try to solve the problem forward, there is some process happening, step by step, but we just cannot efficiently do it. Second hint when maybe this second sign that this should be used is that we're able to say what's the final state. When can't go forward, and it is some process with steps. Don't know how to go forward. And 3 is that you know the final state. Here we indeed can figure out the final state, because I grab all the erases, I mark them as erased, and I run DFS from the top. This way, in linear time, I will figure out what is connected at the very end. And then the next question, but that's obvious. Maybe even I don't need to write this down. We can process the steps or the operations in reverse. This is when you should think about it, the first 3, and the 4th one is obvious. This is just thinking about the solution. rank to each brick as minimum distance from wall, but the distance can vary. Some shortcut can be erased and then you will have longer distance. The paths to the top are not unique, so no MS invent, it's not like that. Degree of stability. You don't understand how complicated the graph can be and how complicated it would be to update anything. I understand that we usually think about easy examples, like, if the graph looks like this, then you will likely figure out how to keep it. But then it looks like that. Now there are two connections. But then it looks like this. And what do you do with that? Somebody, I think, suggested keeping the number of nodes connected to the top. Yes, so what? What happens when you erase that? It's extremely complicated to keep such a graph and understand its format. You as a human, you would see the gaps, you would see when it's cut out, but you look at the whole thing at once and you see, oh, maybe if I remove this, this and that, there is here some cut. How to tell your computer to figure that out? No, I guarantee you that those ideas with degree of stability, with rank as minimum distance, it's not that easy. If you think about details, you will understand that either you cannot define this and you wouldn't know what it is for this drawing, or just you cannot update it quickly. Okay, back to what we do. When I tried to solve this problem in a normal way, considering operations one by one, let's say I couldn't come up with the solution. Yes, we should start with all bricks removed. No, I will not count connected components. I don't think there is a need for that. But I can say what's the final state, because given some graph and marking some nodes as not allowed, I can run the FS from the top and I will say what is reachable from the top, so what is still connected. I can figure out what's the number of bricks existing at the very end that didn't fall down earlier. And then can I do an operation of creating a new brick? What can happen? Let's say at the very end, this brick existed, this one, that, and maybe this is everything that was connected to the top. But now, a new X appears. Going backwards, I see, okay, as the last step I removed this one, so going backwards I need to create it. What can happen thanks to this X is that some new parts of the drawing will appear. Maybe this. All those hashes, this, and that, appeared thanks to creating this X. Can I efficiently do them? Find them? And maybe this step isn't trivial, but yes, I can. If you solved a lot of graph problems, you should here easily say how to do it, by running the FS for neighbors. So when I create X, going backwards, when I create brick X, this create means the opposite of erasing, so I insert. And it's connected to the top. Maybe this is not easy to check, because there are also cases where this X just is somewhere in the middle of the drawing, not connected to anything, so it doesn't do anything. When I create brick X and it is connected to the top, run the FS from all adjacent cells that are not yet connected to the top. So a moment ago, maybe as C, I mark everything connected to the top. Now appears a new X. I will run the FS from this hash, this one to the right. So this is a start of the FS, and this is start of the FS. So for new X, how to check if it's connected to the top? I will iterate the 4 adjacent cells, and I will check if one of them is already connected to the top. If so, X gets connected to the top, and all other neighbors of X get connected to the top, along with their neighbors. This is very easy function. It's the following logic. So new, let's say, brick at row column is inserted. Now for all the neighbors, let's say I can iterate over them. For all the neighbors of this cell, if is connected already to the top of ney, then this cell, this new brick at row column is connected. DFS on row call and the neighbors. This DFS marks me and all the neighbors as connected. For all the pairs in neighbors of this cell, if not connected, then connected. If not connected neighbor, then connected. And is connected of row column is true. This is a bunch of pseudocode. It doesn't compile right now. I iterate over neighbors once to check if any neighbor of X is already connected, because otherwise X is somewhere in the middle of the drawing. It doesn't become connected to the top, so maybe you should think about this connected as is active. And if I see that X is connected to the top, I say that it spreads this disease of being connected with DFS. And for time complexity, what's very much needed is that even though we do a bunch of DFSs, in total this is linear. Because all those DFSs, every cell, they will mark only once. So it's not quadratic. Imagine this. Let's say that you have a graph and there are some disconnected parts. Sure, whatever. One part is infected with a disease. This is infected part. But now you insert a new node, and it is connected to, maybe connected to some neighbors. There are some edges. In our grid problem, there are 4 neighbors. Maybe this one is connected to those 2. And we ask, is something more infected right now? No, because this new cell, this new node, it isn't connected to anything infected. Let's say now new cell comes, it is here, it has those neighbors, and we realize, oh, this cell, this node is connected to something infected. So we mark it as infected, and for each of neighbors as well, we mark it as infected, and they mark their neighbors as infected with DFS. If in total we here deal with n nodes, and in some order they come, with each with at most 4 edges to neighbors, in total all those DFSs are not n squared. No, it is just O of n total, because every node will be colored in green only once. If now there is a new node here and it is neighbors with those, nothing else happens. Now new node here, it is neighbor with those. At least one neighbor is green, infected. And so I mark myself green and I mark those green as well. But it's not that I will go through the whole graph again and again. That never happens. Every node becomes visited by DFS only once. BFS will work as well, sure. I think that DFS is slightly easier. BFS is something more powerful than DFS because it computes distances. It visits nodes in very specific order. But if you cared a lot about running time, about the speed of that, then you should use BFS because iterative algorithms are faster than recursive. It doesn't affect the time complexity, only the real running time. If you care about that percentile in Leetcode, but you shouldn't care about it. Nice point by Jaron Note. In the DFS, you should take care to not DFS on bricks that will be inserted later. That's true. On purpose here, when I created a new node, it appeared in the drawing. It wasn't there before. Consider something like this. Let me Control Z a few times. Okay, it's fine. We can do it like this. If there is a node here, this is a node that is new right now. It is connected to this, maybe to that. So now I will color this. But also, there is this node that doesn't exist right now, but it will appear in 1 second. The important thing is that when you now mark this green and this green, you shouldn't mark this green because it doesn't exist yet. Only when this really is created, it becomes infected, and it also infects its neighbors. Now, the infection is the fact of being connected to the top. This connected component that is right now green, so in this case this, those are all the bricks that are connected to the top. Everything else, it's other parts of the drawing that should exist, but they right now are not connected to the top, so they are not active in some way. You can think about them as grayed out. They should be here, but they do not really. Exactly, Manas is back. Remember that we do the process from the statement backwards. Thanks to that, the new nodes appear. In graph theory, erasing nodes is very complicated. There are problems and scientific papers, theses about dynamic connectivity. You can read all about it. It's much easier to create new stuff and combine with things like find and union, DSU, or just DFSs, than to disconnect things, because you don't know, by looking at this erased node and its neighbors, you don't know if things become disconnected. This is a very general thing about graphs. It's hard to disconnect them. What program for drawing? OneNote. Okay, summarize the steps. I don't know if I will implement this. Yeah, this is bad because I need to finish soon. I wanted to discuss 3 problems, but I went into a lot of detail here. I don't know if this is good or bad. DSU with rollbacks. Rollbacks are something a little bit different than this. You said something reasonable, but DSU with rollbacks cannot be used to say that you keep erasing nodes and you say what's going on. Rollbacks can only be used to cancel some operation that you did a second ago. But in some way, yeah, here we're rollbacking all the way. We're doing this process backwards. By the way, if you're good at competitive programming, you should get the intuition for doing this problem backwards very quickly, by knowing that graphs are easy to become connected. You can do the connectivity even online by creating new stuff, by joining things with DSU, but you cannot disconnect. So in 1 minute you will get the connection. Oh, maybe let's do backwards. But that's if you're good at competitive programming. For Leetcode users, let's say those are my hints of when to apply going backwards. Sedgwick, I don't know what that is. Let's summarize the solution now. Step 1, mark all the bricks, mark as erased, all the bricks that will ever be erased. Run DFS from the top to find bricks connected to the top at the very end, at the end. This is DFS starting from the top, so starting from every brick in the first row, the top row, without going through erased bricks. Now, we know the final step. Not the final step, the final state or the final... We found the, going backwards, we found the initial infected area, the green connected component. Step 3, process now inserts backwards. Every insert means this brick becomes actually available. It's not erased anymore. And if this new brick row column has at least one infected neighbor, run DFS from row column and mark everything as infected. If it isn't infected yet and it's not erased. Not infected and not erased. Erased meaning not existing. That's the solution. "217, you're spamming so much, I will soon remove you from the chat." Is this really what you think should be discussed now during the stream? It's like the worst time. I'm good at coding, I should participate in Code Jam, you think? Maybe. I heard there is this Code Forces platform. I wish I also heard about ICPC when I was in university. I would be happy to try those team competitions, you know? Or create some problems myself. Now, it's clear to me that we will not do rank transform today. I don't even know if I can implement this. Hash set with erased nodes. Don't use hash set if something has only small values. In this case, we deal with constraints 200 by 200. Hash set is very powerful, but it also is slower and it has some big overhead. You know, it's very complicated under the hood. No, I will have Boolean array is erased, 200 by 200, and is infected, 200 by 200. This means connected to the top. I drank water seconds ago. Stop it. You're bullying me. Arrays are easier to use and they are faster. Copilot, I heard that Copilot sucks. in particular, I don't know about copyrights. Bully is being bullied. You want a ban? Would the order of insertion matters? Oh yes, it matters. You need to do it backwards, not in random order. Number of nodes that you secured within the DFS. Yes. In this, let's see, there is this DFS. I will temporarily move it up. DFS is infected of row column is true for all the neighbors. Let's say that the neighbor is R2C2. If not is erased right now, so it actually exists, and not is infected. C2. Let me go full screen. Then DFS and additionally, when I mark as infected, count infected plus plus. Okay, this is global, starting from the end. This starts as 0. In this step, in the second step, this one, for every topmost brick, if it's not yet visited by DFS, so it's not infected, this is like is visited array. Then I run this, and so this automatically will count what's the number of infected cells at the very end, and then going backwards, when I insert a new cell with this algorithm, I will, if it has at least one infected neighbor, it will trigger some other infections, and the count will be updated. So maybe at the very end I will realize there is some answer array, initially filled with -1s or whatever. At the end I run DFS from the top once. Let's say that count infected is 5. I put 5 here. I run for some previous, for the last, I look at the last operation. I insert this brick. Maybe it doesn't do anything. It doesn't become infected. So count infected is still 5. Next brick, going from the end. Oh, this one becomes infected and it triggers a lot of more infections. So apparently this one, when it was erased, when going forward, because of that, a huge part of the drawing dropped down. Maybe 10 new nodes become infected. Count infected is 15, so I put 15 here. So it's like going backwards, queries -1 down to 0, like insert this brick, and then do answer of I is equal to count infected. Teki-chan, yes, brick remains erased when going forward, so it remains inserted when going backwards. Assign value to each brick, moment when it was deleted, longest path. I see. It's a nice solution. That's a very nice solution. Okay, so the thing by Maxim is something worth discussing for sure, but I don't have time for this today. I need to run right now. We'll do this. Either I will make another short stream tomorrow, I'm not sure about that. If not, I will put a code of this, I will implement this solution, and I will put it in YouTube comments. Here on YouTube Eric22 channel, you can watch all the recordings of streams, in particular this one, Leetcode hard problems are easy. In comments here I will put link to my code. But now sorry, but I need to run. Sorry for not finishing the code. But you have homework now. Implement this. If you understand it, you should be able to implement. And think about rank transform. Join the Discord. Be nice to others. Drink a lot of water. Thank you for watching. Bye.